So today we are doing lesson 3. It's about electromagnetism. We are going to be...
What? In hardcover?
Yep, it's in the hardcover. Yep. Okay, so we are going to be working on what's called the frame routine. It's a new way to kind of take notes. It helps you gather the main ideas and the big concepts from the reading. So I'll go ahead and pass out these sheets. This is what they look like. So we'll read the passage together, and then we'll kind of fill out the sheet together as well. Alright, so it's just kind of a new style of taking notes and remembering the big concepts. And then, you can always use this in your other classes too, and if you plan on attending college and stuff like that too. So to kind of review some of the words that we have coming up, here are some of the words that are going to be hard to pronounce, and then we also have like the vocabulary if it might be a little difficult. So Hans Christian Ørsted, we're going to pronounce that Hans Christian Ørsted. And then we have electromagnetism, and we're doing that electromagnetism. And then that is going to be the action between magnetism and electricity, so it's kind of how they come together. For the solenoid, that's sol, like mol, and then n-oid. And it's kind of just a coil of wire. It's used to increase the magnetic power through the current. And then for electromagnet, it's kind of just the same as magnetism, but without the ending. So electromagnet. And then that's an iron bar with a solenoid wrapped around it. And then aligns, when things go together, aligns. And then exerts, when it pushes it through. All right? So we can read the passage together as a class. Is there anyone that wants to start? No? Okay, I'll start for a little bit, but then I'm going to call on someone else to read, all right? So, first of all, the relationship between magnetism and electricity. A compass needle is a magnet. The needle points north because of Earth's magnetic field. If the compass is in a different magnetic field, the needle will not point north. In 1820, Danish scientist Hans Christian Ørsted experimented with magnetism and electricity. He held a compass near an electric current flowing through a wire. He saw that the needle did not point north. After more experiments, he concluded that the current in the wire produced a magnet field. All right. Who wants to continue? All right.
The action between magnetism and electricity is called electromagnetism. Ørsted's experiments show that the direction of an electric current magnetic field depends on the direction of the current. Electric current flowing in one direction causes a compass needle to turn clockwise. Current flowing in the opposite direction causes the needle to turn counterclockwise. The magnetic field produced by such current is weak. It's strong enough to turn compass needle, but it can do little more. Two devices can increase the magnetic power of an electric current. They are solenoids.
Yep, solenoids, yep.
Solenoids and electromagnets.
All right. All right, you want to go ahead and read solenoids then? Continue. Thank you.
The current and flowing in through a loop of wire generates a weak magnetic field. If the wire is looped many times, means its magnetic power is increased. This coil of wire is called a solenoid. When electric current flows through it, a solenoid generates a magnetic field like that of a bar magnet. The end of a solenoid exerts its greater magnetic force than the middle. The magnetic field of a solenoid can be straightened in two ways. The number of loops in the coil may be increased, or the current flowing through the coil can be increased.
All right, Cameron, you want to continue for us?
The magnet field of a solenoid can be made hundreds of times stronger than placing an iron bar inside a coil of wire. An electromagnetic is simply an iron bar with a solenoid wrapped around it. When the wires are connected to a battery, electric current flows through the coil to produce the magnetic field. The magnetic field of the solenoid aligns the domains of the iron core. The iron core becomes magnetized. The resulting magnetic field equals the magnetic field of the solenoid plus the magnetic field of the iron core. The combined magnetic fields are far more powerful than the solenoid.
All right. Yvette, if you want to read this first paragraph, then I can finish it up for us.
Electromagnets have many useful applications. They are used in things as small as a doorbell or as large as an electric generator in a power plant. Electromagnets are temporary magnets. They can be turned on and off at a salvage yard. An electromagnet is turned on to pick up huge metal objects such as cars and refrigerators. When the electromagnet is turned off, it releases the object.
All right. Many machines use electric motors. In an electric motor, it can convert electrical energy into mechanical energy. Current flows through a coil of wire between the two poles of an electromagnet. The electromagnet exerts a magnetic force on the wire and makes it rotate. The rotating wire starts the motor. A ring attached to the wire causes the electric current to change directions. The repeated change in direction of the current keeps the motor running. All right, so any questions about anything in the passage at all? Okay, so we can go ahead and fill out this sheet right away. We can kind of do it together as a class. So for the first part, we're looking for the key topic. Does anyone know what a key topic would be? Like a definition for a key topic, maybe?
The main point.
Exactly. Yep, exactly. So what do you think would be the key topic in this passage?
Electromagnetism.
Yep, exactly. So the title of the passage can refer back to the main idea. Usually it kind of gives you like a hint about what it's about. You want to fill this out with us? We're doing electromagnetism as the key topic. Okay, so then under that it says electromagnetism is about ... So what would we say that electromagnetism is about?
Electricity and magnetism.
Right, exactly. So it's kind of the action between the two. And remember we wrote that one up here on the board too. So we could use that in the is about section, this part right here. Okay, so then we're going to put 3 main ideas down from the whole passage. So we can kind of go over all of the main ideas first, and then we can fill in the details after. So what do you think one of the main ideas from the passage would be?
The relationship between magnetism and electricity.
Yep. So that's actually what I have for my first main idea too. So we can just write magnetism and electricity if that kind of shortens it up for you a little bit. It's just kind of an easy way to remember the key topic. Or excuse me, the main idea. Okay, so then for the second main idea, this box right here, what do you think that one would be? What do you think was one of the important takeaways? I think the key terms kind of help with the main ideas too.
So like the meaning.
Yeah, so kind of just let's do another main idea from the passage. So we'll have three altogether. So magnetism and energy, or excuse me, electricity was the first one, and then for the second one, what did it kind of talk about for a big chunk of the passage in?
Between the magnets.
Yeah, so the current between the magnets, that one would probably be under the first one, right? So I was thinking that the solenoids was kind of a big part that they talked about in the passage too for the next main idea. So we could go ahead and put that in the second main idea box if you'd like. Okay, so then for the last main idea, what did they kind of finish up with talking about in the passage? Like, what do you think was a big chunk that they kind of talked about a lot? Yep, exactly. So we'll go ahead and put that for the third one in the third main ideas box. Okay, so next up we have the essential details on the page. So how do you know which information is important from the text? Like how do you determine what to take away and what you want to remember? Does anyone have any ideas?
Who came up with this experiment?
Yep, that, like how it started, maybe how, like key terms, those usually give you important details too, and then things that can relate back to the main ideas. So we can go ahead and fill in the essential details for the first part. So these boxes right here, these four. So for our first one, we have magnetism and electricity. And then you said, Yvette, you said how it started. So who started it?
Hans Christian Ørsted.
Yep, so we could go ahead and put him in the first box. And then do you remember what he did with it?
He experimented with magnetism and electricity.
Yeah, so you could just go ahead and put that in the first box that he kind of started the experiments and then what the experiments were.
Okay, I'm going to be gone tomorrow, so that might throw him off a little bit too. Yeah, so, and Friday, so, yeah, so just an FYI. Okay, thanks for letting me know. All right, bye.
Okay, so then for another essential detail, what do you think is something important that we need to remember about magnetism and electricity? Cameron, did you have any ideas?
No.
None?
No.
No ideas?
No.
Okay, what about you, Sienna? Anything that you think is important that relates back to the magnetism and electricity?
Electromagnetism, the action between magnetics and electricity.
Yeah, so we could go ahead and you could fill it in, but we kind of talked about that with the key topic too. We kind of already have that on the paper. So it is important to know that, but in reference to magnetism and electricity, maybe we could talk about. You have an idea? Yeah, Yvette?
I don't know if she just said this.
Yeah.
But the action between magnetism and electricity is called electromagnetism.
Right. Okay. So yeah, that's what she just said, and that's really important to know. But it's the key topic of the passage. Remember, we already have that written down. So we want to make sure that we are writing down the details that are important to magnetism and electricity. So how about,
Would it be another detail about what he did?
yeah, sure, that would work too.
That he held a compass near an electric current flowing through a wire.
Yep, we could go ahead and fill that in because it's important with the experiment that he conducted. All right, so we talked about electromagnetism and we decided that that's a pretty important part. That's basically the main idea, the key topic. So, what if we try to find an important detail that they explain in that paragraph? So, the second paragraph, when they give the definition for electromagnetism, is there something else in that paragraph that you think that we should put on our sheet there? All right, I was thinking, because we were talking about his experiments, they show that the direction of an electric current's magnetic field depends on the direction of the current. So I was thinking that we could put something about that in there because it's important to remember what the experiments that he conducted were with. Okay, so how many do we have? 3 so far?
Yeah.
Do we want to do one more or do we want to move on? Okay, so to the next main idea, the solenoids. First of all, it gives the definition of a solenoid, so we could put that in the first detail box if we want to do that. I think that's pretty important.
Wait, first it means?
Yep, so for the second main idea, we're right here on the solenoids, and then we'll go down to these details. So,
Would it be the current flowing through or the coil of wires called?
we could actually put both of those in too, because those are both important to know what solenoids are. So we could do the definition of the solenoid, the coil of wire, and then we could kind of talk about the current flowing through a loop. Okay, so then what is something else that you think is important about solenoids? Cameron, what are you thinking? Okay. What about Sienna, do you have any ideas? Okay, how about if we go to the second page, right before they start talking about the electromagnets, they talk about the solenoids a little bit more on the next page. Could you maybe find something in that section that would be helpful to remember?
Hoops in a coil, or if it like make it
Yeah,
stronger.
yeah. So that we could put in one of the detail boxes too. So, did you hear what Yvette said for one of the boxes? The number of loops in the coil may be increased. So this part she thought was important that we could put in the next detail box. All right. So, are we ready to move on to the next one?
Yeah.
Yep. All right, perfect. So, last main idea, electromagnets. They kind of have two parts about this topic in the passage, so we can kind of get some. There's probably a lot of essential details that are there to remember. So, what does anyone have any ideas about the first detail that we should use?
The definition.
Yep, excellent. That's what I was thinking too. So we can go ahead and put that in the first box. Electromagnet. And then we also have it up here on the board too. So if you just want to look at that and put that in, you're welcome to use that as well. All right, are we good to move on to the next one? Couple more minutes. Okay, so something that might be important is to know how it works. So you think there's anything else in that paragraph about electromagnets that we could use as an important detail to remember? Okay.
The magnetic field has something to do with electromagnets.
Yes, but let's see. What are you thinking, like the first part of that paragraph? Or,
When I saw it,
yeah.
Because when the wires are connected to a battery, electric current flows through the coil to produce a magnetic field.
Yep, I think that sounds pretty good. So we can go ahead and put that one in the next box here. If you couldn't find it, it's right after the definition of electromagnet. So it's that following sentence. So we could go ahead and put that in the next detail box too. If you want to shorten it up, you could say when it's connected to a battery, the electric current flows through the coil to produce a magnetic field.
When connected to a battery.
What was that?
When connected to a battery.
Yeah, when connected to a battery, electric current flows through the coil to produce magnetic field. Just because it's kind of long written there. Alright, so we can do one more detail about electromagnets, maybe something that we find in the last section about using them. It can even be something little that you just think is important to remember about the electromagnets too. Cameron, what do you think? Under using electromagnets, is there something in there that you think that we should remember?
The last sentence.
Which one?
The combined magnetic fields are far more powerful than a solenoid.
Yep, that sounds good too. So we can go ahead and put that in the last detail. So that's in under the electromagnetics passage, just the last sentence. That sounds great too. So if you want to put, I think just this combined, that's the one that he was talking about that we should be sure to remember. Alright, so then for the last box on the sheet, it says, so what? And what's important to understand about this? I think it's important to kind of know why we learn this and why it matters. Basically, in the passage, it talked about how people could use how people use electromagnets in everyday life. So does anyone remember what are some of the ways that they use them, that people use them, maybe in work or at home or anything like that?
Like in the picture of the crane operator.
Yep, so we could talk about that. Another thing I thought was important is that it said that they're used in things as small as a doorbell. So how often, when you go over to a friend's house and ring the doorbell or anything like that, you don't even realize that you're using it. So that's why it's important that we're learning about these things so that we know how they are applied in everyday life too. So just in that last box, if you just want to put what you think is important overall and why we learned it and why it matters, basically. There is another example in the text too, so if you want to look at that again, you're welcome to check that out too.
What do you see?
So, back in the last paragraph, it talks about the doorbell and then also the electric generator power plant. Yep, so that's the one I was thinking about too. These are kind of the everyday use ones. Alright, so we're just about done. Just to kind of review the sheet that we just worked on, as far as the key topic goes, we talked about how to kind of identify that. Usually it's kind of sometimes the title, right? Kind of gives you the idea of what the passage is going to be about. And then as far as the main ideas, what are some tricks we could use to kind of pull out the main ideas from the text?
Subheading.
Yep, subheadings, that's a good one. And then as far as the details go, how do you know what's important to take from the text? What's the first detail we have?
Person's name.
Yep, so who started it, how it kind of came about, definitions too, those ones are useful. And then it's always good to remember why it's important and why we're learning it, right? Because we're not just learning it for nonsense. It's important to know in everyday life too. So, are there any questions about anything we covered, about the worksheet, the reading, anything? All right, then we're all done here.